Our third speaker today is Grant Bowers of Garrison, where he's a firmware engineer. He began his career on SIL SIL 1 verification projects with UVM. Over the past 3 years, he has been leading FPGA verification efforts at Garrison utilizing cocotb. He is based in the UK, and the title of his talk is How cocotb saved us thousands of pounds and thousands of hours. Over to you. Thank you, Grant.
Cheers, Mike. So, I'm going to talk today about how cocotb has saved us thousands of pounds and thousands of hours. So, as opposed to the past talk, it's going to be a bit lighter on detail of how to write a test in cocotb, but it's going to be more of a focus on how you can use cocotb to change the way you do verification and show you how you can do some pretty interesting things with it. And actually, as I was writing this, I found saying thousands of hours was actually probably a massive understatement when I started actually looking at the numbers, which I'll show you later. So there we go. So I'm gonna give you a bit of an introduction to Garrison because I imagine most of you, well, all of you, are probably not familiar with us. I'll talk about why we switched over to cocotb, and then I give you an overview of our sort of simulation framework, and then talk about CI, so continuous integration and regression testing, and the stuff we've done with that, and how cocotb's compatibility with lots of simulators has helped us save a lot of money and time and run a lot more tests. Okay, so quick introduction to Garrison. So we provide isolation and cross-domain solutions to government and critical national infrastructure. So an example of one of the things that we provide is, so this is our browser isolation. So this is hardware which essentially allows people on network to access the web where they wouldn't normally be able to access the web. So they send keyboard and mouse clicks and through hardware, and video and audio of the web is sent back. And we use FPGAs in our designs to ensure that inbound data to a user is transformed into a provably safe format. So I came to Garrison 3 years ago after working on mission critical verification of ASICs using UVM. And there was a lot of VHDL test benches, and they were using a tickle-based workflow. And I'd not really looked at that sort of thing since sort of the start of my career when I was using OSVVM. So I was quite unfamiliar with it all. But I was tasked with trialing cocotb, and since then I've spent the past 3 years working on it. So I've been leading verification and working on sort of like process and quality at the same time. Because we have security enforcing RTL designs that has quite a rigorous sign-off process. But cocotb's let us be productive with our test benches, and it also integrates well with our sign-off process because it allows us to do more testing and more automation. Okay, so why did we switch to cocotb? So it was originally because we had we have a proprietary data protocol which is described in SCAPI, which is a Python package that is used for describing protocols. And it's worth saying our main HDL at this point is VHDL. So, and then we also had a lot of VHDL test benches where Python was pre-generating a lot of vectors and stimulus using those SCAPI definitions, and the VHDL was parsing the outputs of those for tests. This meant tests took a very long time to run because we were doing a lot of processing of data files in VHDL. And given how many simulations we run, which I'll show later, this ate up a lot of project time. And alongside this, Garrison is a heavily software-based company. So sign off on our designs included code review of our tests. And it's difficult for a software engineer to sort of context switch to review Tickle and VHDL test benches, because it's quite an unfamiliar language to them. And then at the same time, when considering what to switch to, the cost for licensing and training for UVM, sort of a massive barrier for entry. I mean, I was already a UVM user. I'd been using UVM for the past 4 years before this. But the rest of the team, it's quite hard to bring a team up to be able to be proficient and writing useful tests in UVM. So we switched to cocotb, and then straight away we sort of saw the benefit. So the first test benches I wrote they had encryption and hashing functions inside them, and writing the models for this. And where you're writing a model is typically where you spend most of your time in your test bench or bringing a test bench up. But Python made it very simple, because it's just a package that does it for you. So we could use like the whole ecosystem of Python when we were writing models. And then where the drawbacks of cocotb, like mentioned earlier, the main bottleneck is where you're interfacing with the simulator. That sort of paled in comparison to the amount of time it took for us to use text.io to read generated vectors from our SCAPI definitions. We could now generate that data at the point of using it sort of in our sequences and our transactions in cocotb. And it also made the code much easier to review. So we spent less time and money on simulators, and we had more productive engineers who had all of Python to help them write tests. And it also makes recruitment and onboarding a lot easier. So it's easier to train an engineer in Python than it is to train them in UVM or OSVVM or other frameworks that you could use. Because Python training is abundant, and also design engineers can easily pick up better verification practices because they can see a framework and then they can look at Python and it's generally quite easy to follow. And there's not that it's quite easy to abstract away a lot of the bits that would confuse a design engineer. So I'll talk you through our test bench structure. So we needed a structure for our test benches because we had all the freedom of cocotb. So when you sort of move across, you realize you can sort of do what you want when writing a test bench. But we still need high quality verification and we still need structure to our test benches because at the end of the day, it needs to be signed off. But with cocotb and other coverage packages, so cocotb coverage is the one we use, and I believe there's a couple others I'm aware of, and also bus pack, so cocotb bus package, we use Avalon interfaces, so we use that, and with that we can produce test benches, and this structure or this framework it should be familiar to anyone who works in verification, but if not, it's the sort of general structure you see in all of the frameworks really. You have the tests that generate sequences which are passed to an agent which talks to a model and a DUT, and then you use that to feed into a scoreboard to compare the two, and then you generate coverage to prove that you've done enough testing. So yeah, we're still doing a lot of work on test framework as well. And yeah, someone asked in the chat about PyUVM. That is something. So we've sort of had it on the back burner to look at PyUVM, and we also came across Forastero, I think it was recently. So there's a few to look at in terms of actually structuring a cocotb test bench. But with Python and cocotb, we can write code which is reusable and readable. So um, we spend less time writing boilerplate code because all of these bits of the test bench that you see are reusable components. So we spend less time on boilerplate and more time actually writing tests. And then, okay, so this is an example of how what packages we use with cocotb, and what's really helped us with our productivity when writing test benches. So yeah, I mentioned earlier that we use a crypto package. So yeah, I use that to help me write a model for a duck, and it was simple. But however, more recently, we verified a duck which had a low pass Butterworth IIR filter inside it. So we needed to do some signal processing. Um, and actually talking about that test bench is how this presentation came about. And I think it's a good example of sort of the power of cocotb. And it's especially interesting given how little relative effort went into writing what would be quite a fairly complicated test bench. Um, so with it, we had a model, and writing the model was simple using SciPy, which has a filter component, and it just gives you a configurable filter that you could use in your model. So that helped us writing that test bench. But then, more interestingly, we were also able to parse and produce WAV files, so audio files, um, with a different package. That was with the Wave package, and we could we could automatically generate these WAV files as part of the test bench and pass them to a software team or people with because as a verification engineer, I don't know so much about audio and signal processing. However, being able to generate a WAV file and pass that to someone who does, and it's also something we can automate with Python. It's really powerful, and yeah, it was quite an interesting test bench. Um, and then on top of that, we used to use make files with cocotb when we first started. So this was 3 years ago. So this was before Python runners were available in cocotb. But then along the way, we picked up cocotb test, which I believe has now been merged into cocotb. However, we've written a lot of wrappers around this to sort of help and made some modifications to help it with our workflow. So we've done things like adding fixtures for parameters and using Monkey Patch, which is a Python tool for configuring your environment. So things like environment variables in your working directory. And yeah, picking up PyTest was really sort of the missing link for us to fix a lot of problems we had with our workflow. We could do a lot of testing we do a lot of testing where we parameterize hardware configs. And previously it was hard with makefiles and using the test factory to invoke the simulator for each test. And we had issues with the sort of the simulator, so the duck not restarting or the simulator not restarting when we between different tests. But with PyTest, it's much easier, and we can also use parameterize, which is a PyTest fixture, to parameterize our tests, so we can generate tests with Python. So yeah, you can use whatever you like in Python to define those parameters and then fixtures to generate the tests. And yeah, we could also set a lot of these fixtures. So for those unaware, fixtures are a PyTest feature where you can hook things on to the start or the end of your test. And yeah, it allowed us to move a lot of the code that was living inside our cocotb test benches out of it into the PyTest fixtures, and sort of uh, take away a lot of the stuff that did the heavy lifting, but confused and made it hard to read, and sort of obfuscated it from people coming to pick up a test bench, and it made it a lot easier to grasp for newcomers to test, and most of the design engineers looking at testing. So that's things like hooking up the Python debugger, is a block of code that is not a very nice block of code, but you're able to, and it typically appears on all test benches, but you can move it out into a PyTest fixture, and then it's away. And then this bit's quite interesting. So we have a lot of pre-sim scripts. So these are the things I spoke about earlier, where we were previously doing it before the VHDL test benches. A lot of these scripts basically haven't changed since we moved to cocotb, or at least not because of our new workflow, not driven by cocotb. So yeah, these are scripts for generating IP or generating HDL, and managing dependencies throughout our repo. And yeah, there's been no need to change it, other than just adding it into our PyTest fixtures. So I think it speaks a lot on how easy it was to change over to cocotb, given that we already had a wealth of Python scripts as part of our workflow. And then afterwards, so we have a sign-off process for our designs, and that's mostly driven by continuous integration, which I'll talk on for the rest of the presentation soon. But yeah, we can generate a lot of metrics from our tests because Python and cocotb has an open interface, and we can pull data from our tests and things like coverage and functional code coverage and functional coverage and all manner of things. And yeah, we didn't really have this in mind when we first started with cocotb. It was more focused on the productivity wins. But yeah, this is something that came about. And emulation as well. It's far easier to hook up, sort of do hardware in the loop testing with Python, because Python's generally good at interfacing with other languages, whereas there's a lot of proprietary IP that's typically required to do emulation with, say, UVM. So yeah, like I said, I'm going to sort of spend the rest of the time sort of showing you how we use Python to do a bunch of cool things. So it's all continuous integration. And so continuous integration is the idea of constantly testing and building every time you make a change when you merge them into a main branch. And it's not really something that comes up often in the world of FPGAs and ASICs. I mean, I've been coming to conferences and meetings like this for a while, and it's rare you hear CI spoken about. But we've got a massive push for it because we're a software focused company. And cocotb has really helped with that. We haven't really had to deal with any nasty interfaces to simulators to get data out of our tests, and it integrates well with our DevOps platform. So this is what our test environment looks like. We use WSL with Docker and VS Code, and then we use containers for all our tools, and that's shared between our development and then our regression testing environment, which is GitLab, which uses Kubernetes to orchestrate all of our test jobs. Yes, so we're using the same containers across everywhere. So it's important because now we're using Python, where we've got lots of different packages and tool and simulator versions. It's important using containers because it prevents any issues there. And then I'll quickly run through this. This is how our containers are formed. So it's all layered. So we have the configuration of the operating system, and then more generic tools like Scapy and MyPy, which is a linter. And then on top of that, we have so that we fork from our like base container, so what's used for builds, and we layer some simulation tools on top of it, like cocotb and cocotb coverage and wave viewers. Um, and then the interesting bit about this is we can then layer the simulator on top because cocotb is good at interfacing with a lot of different simulators. It's basically the same. So other than just switching the tool out and changing the scripting process, we use cocotb with GHDL the same way we use it with Riviera. So yeah, we use Riviera as our main simulator, and Aldex support has been really good. We found bugs and they've sent us a patch out the same day. But it works as well on open source as it does on proprietary. And that's a big win for us because it means we can switch simulators based on our needs. Like someone said earlier, if we've got a block of encrypted IP that only works in Riviera, or if we have a test that takes a long time, we can use GHDL or Verilator to run it because they're obviously a lot quicker than well, they are. It's not obvious, but they are a lot quicker than other simulators due to the way they work. And this has helped us fix the main bottleneck of our development, which is licensing, which means we can run more tests more often and spend less time waiting for licenses to run a test because we can just switch to a different simulator, and cocotb doesn't really cause any friction with that. And this is our basic workflow. So this is like a typical feature branch workflow where you find a feature, you create a ticket, you development, and then you review it. And we use GitLab for our version control and CI. And basically in GitLab, we have a flow which automatically runs our pipelines every time we create a merge request. So a merge request is like a pull request in GitHub, and we run nightly regressions. So pipelines are a GitLab CI tool which group together and orchestrate a bunch of jobs. So obviously we're interested in testing and metric generation, and now we use PyTest. So it was good when we used makefiles interfaced okay, but now with PyTest it runs really well. We had a lot of experience running Python on CI anyway, so setting all this stuff up was really easy, and it means we can find bugs earlier because we're constantly testing. But it also means we've run a lot of tests. So on the top graph, this is our annual pipeline runs, and you can see that we run an average of about, I don't know, 4K, between 3 and 4,000 pipelines a month, which is a lot for a small team. And so a pipeline is a bunch of jobs. So it could be hundreds of jobs in a pipeline because we generate jobs on pipelines. And you can see underneath this, so I pulled together two of our largest groups of tests. So they're for two different hardware configurations. And in total, there's 650 tests and that'll take 127 hours to run altogether, 5 days. And for a small team, that's quite a lot. And these pipelines are triggered every time we will make a change that's got a merge request. That's something that needs to be reviewed and nightly. And cocotb's it's allowed us to basically run these because we can switch between simulators. We can arbitrate based on our needs, which I'll quickly talk about. So we so because of how easy it is to switch between simulators with cocotb, we can sort of trigger jobs in CI based on different needs, like if it's a release branch or if there's a tag on it. And you can see a shortened view of our pipeline at the top. So we have a linter and then we generate a load of jobs. So we have a sim configuration job, which looks for our repo and finds all of our cocotb jobs or simulation jobs. And it generates them, and then we can use a license. Well, we do use a license broker, which basically, we can sort of arbitrate jobs based on license numbers, and then you can see on the right at the bottom, these are all our generated jobs. So we generate jobs for Riviera or Questa or GHDL. And it's I think the interesting bit is the ability to do it on the fly, which cocotb does let us do because it's not hard to switch between simulators with it, which is a big win. And then finally, the last thing I'll talk on is so when we first set out with cocotb, we didn't really intend to we didn't really think about the ability to do all these sort of metric reports. So these are views from GitLab, but we do also use Grafana and Open Metrics to generate metrics. However, it's less mature for that. But yeah, because cocotb uses JUnit, which is a standard results format, we can use Python to generate metrics during and after our tests and pass them up to our reviews. So at the bottom, you can see where we've generated functional coverage and we've generated code coverage results. So the one on the left-hand side, you can see for these GHDL jobs, we achieved this % of functional coverage for this test. And basically you can put whatever you want as the coverage. So it could be code coverage, it could be functional coverage, and it's split up by tests. And then on the right hand side is so this is the graph of it's not a very interesting graph because you can see in August we wrote this test, and then the code coverage has stayed the same because we've not touched it. But we can get graphs of code coverage over time, so we can see in our reviews how you can basically see the benefit. So say you've written a test, you've added a new test case. You can see if you've achieved what you've achieved by generating coverage as part of the review.
Hi, Grant, you have 2 minutes left, by the way.
Yeah, there is. And then at the top is inline code coverage. So we generated this with cocotb and GHDL. So this is fully open source inline code coverage as part of our review process. And it's been really powerful to add all this to our reviews. And there we go. That's the end of my presentation.
Thank you very much. Just one question about whether there's randomized code stability or not.
Yes.
Yes.
So this is a big problem we had. So Python, and so the way Python generates random numbers does cause issues. Say you change something in one place, it will change it further down the line in your test bench. And we've had to use a singleton format and a random number factory to fix that.
Okay, but there is a solution. Brilliant. Okay, thank you very much, Grant.
That's okay.
So thank you for your participation today, to our sponsors, Agnesis, Cadence, Synopsys, and Brecker, and TestSolve. I saw some chat on Teams. Yes, the presentations, both the slides and the recordings, will be available. They go up on the DV Club webpage, and you will get notification of that. But if you go to the DV Club there and follow the link there, you'll see it appear. The slides should be done today. Recordings usually take a week. Suggestions for ideas. Again, this talk came from a request from somebody. So we do listen to your requests. We do put on talks that people ask for, because obviously they're the more popular ones. So just send your requests and ideas to me. If you want to speak as well, you can always volunteer yourself as a speaker. Very good career move, as well. So, and upcoming events. DV Club India, which is actually physically held in Bangalore, but online as well, 19th of November 2024. We're verifying chiplet-based systems. If you don't know what that means, it's UCIe and chiplets, rather than single SoCs. FPGA front runners, which is focused on FPGAs, but I noticed we had quite a few FPGA people registered for this event, and we're focused on FPGA safety and security. That's going to be in Cambridge in the UK on the 21st of November, but again online. And our final DV Club Europe of 2024 is on the 26th of November. Okay, it's on the use of AI and ML in verification, a very hot topic. Okay, so again, thank you to our speakers and our sponsors. And yeah, a big thank you to our 3 speakers today. So Haida from Wärtsilä in Finland, thank you. Philip of the Fossey Foundation based in Germany, and Grant Bowers of Garrison based in the UK, who was thank you for stepping in as well. And thank you for everybody for joining, and we'll see you at one of our future events. Thank you.
Thank you. Thank you, Mike. Thank you, everyone.